Okay, so thanks everybody for joining. This is being presented by the Carbon Leadership Forum's Austin Hub. And we're having Mark Thimons, Lionel Lemay, and Dangel join us to give talks about different sustainable building materials. So we'll talk about wood, concrete, and steel. And I'll let them give their own introductions. But to give a brief overview of what we're talking about, I'm going to quickly go over the Carbon Leadership Forum, what we do, what we're about, and they'll each have roughly 15 minutes to talk and answer some quick questions, and then we'll open it up for discussion and Q&A at the end. And then for the 30 years following that, I want everybody to make sure you're talking about embodied carbon as much as possible, bringing it up on every project and using what you learn here and in future presentations. So about the Carbon Leadership Forum, it was founded about 10 years ago. And it's all about collective action. It's all about bringing people together to talk about and address embodied carbon in the built environment. And so we recognize the impact of buildings is significant. There's research that's conducted, so people involved either in academia and industry, and then we develop tools and resources. I'm sure many of you have heard of the EC3 tool. That was an idea that was incubated in the Carbon Leadership Forum, and we empower collaboration and connect a whole bunch of members all around the globe to talk about embodied carbon. There are local hubs all over the place. Austin is just one of many. And so I think most of the people on this call are probably joining from Austin, but those of you who aren't, look for a local hub near you and see if you can get involved and join in. And there's also an online community that you can join. So if you go to community.carbonleadershipforum.com or .org, there's an online forum that you can ask questions, participate in. It's been called kind of the Google search of embodied carbon. And there are a bunch of focus groups as well. And so we have local hubs, there's an online platform and focus groups. So if there's a particular idea you want to develop or incubate, start getting involved in the Carbon Leadership Forum, and this is a great place to start. As far as the CLF Austin, so I'm just one of 3 leaders in our hub that we all organize these events. And so I'm joined by Greg Arcangeli with Austin Energy Green Building and Dulce from Carrasquillo Associates. And with that, I will pass off the torch to Uli, because I know he has a hard stop at 12:30, so I want to make sure you have time to present first. So let me go ahead and stop sharing.
Thank you. Yes, thank you. Let me get this going here. Thank you, Martin, for the introduction, and also thank you to you, Dulce and Greg, for inviting me and the opportunity to speak here today. It's going to be quite concise, 10 to 15 minutes. I'm not going to go, super specific, but I just hopefully some of the things that I'll talk to you about will be news to you. I'm assuming a lot of you on the call today, and thank you for joining us, our kind of expert when it comes to carbon. I really want to talk about wood and sustainability and some of the concerns that we have there, and then also opportunities going forward. So I'm an associate, I'm an architect by training, I'm an associate professor, and I'm currently also the program director for architecture at UT Austin. And my research has, over the last 10 or plus years focused on timber, and more specifically mass timber construction. That doesn't mean I don't deal with other building materials. I also teach structural design courses involving steel and concrete as well. But wood kind of is something that's close to my heart, also partially due to my Austrian-German background and upbringing. So with that, I'm going to launch right into it. I mean, wood is, besides bamboo, wood is really the only structural building material that is alive. It comes out of our forests, so we have to harvest it. And our forests contain 80% of the Earth's terrestrial carbon. So when it comes to our carbon emissions, we really have to take a close look at where's our resource coming from? Where's that wood coming from? I mean, wood itself or trees themselves are really amazing things, right? They take up carbon from the atmosphere and through sunlight convert that carbon dioxide and water into carbohydrates for their growth, and then simultaneously release oxygen that we all need to breathe and live. But you can't have a conversation of, when you're talking about wood and not talk about deforestation and the concerns of that And then that's, you know, if you talk to any layperson, that's kind of the first thing that comes up. Aren't you cutting down all the trees? This is a map that I generated based on FAO data on the annual net forest gain and loss between the 25-year span between 1990 and 2015. And you see that we've done really well in the Northern Hemisphere. I mean, Canada had some, you know, losses during that time period, but caused by natural disturbances, not over harvesting. I mean, you know, once we include probably what happened this year, especially in the United States, California, Oregon, and Washington, that will probably look a little bit different. But you can see that we've been doing pretty well in the Northern Hemisphere. The Southern Hemisphere, you know, there are large amounts of deforestation happening, but most of that occurs when land is cleared for agricultural uses, in particular the cultivation of highly profitable commodity crops or converting it into grazing areas for livestock. And you can see it, Brazil here being dark red. It's the second largest producer of soybeans in the world, second largest producer of beef. Indonesia, dark red here, the largest producer of palm oil. So it has to do with, you know, other things than just using wood for construction. That said, we still have to be mindful where that wood comes from. And I'm obviously an advocate for sourcing the materials that we use and making sure that they come from sustainably managed sources. Wood is the only structural material that has third-party certification programs that verify that the product originates from a responsibly managed source. And again, you know, in the Northern Hemisphere, I mean, Europe has been managing its forests sustainably for over 400 years. In North America, we're, you know, probably about 200. And here in North America, about 30% of our forests are certified by FSC or PEFC. And that doesn't even include all the federally managed forests that are sustainably managed, but do not fall into a certain certification program. So, you know, I'm an advocate for using wood, but I'm also advocating that we use wood from sustainable sources and make sure we can trace that resource. Really, the goal, you know, the great opportunity for using wood is capturing that atmospheric carbon that the trees absorb as they grow. As forests mature, that kind of tops out, and older trees, more mature trees, absorb carbon much more slowly. So there's an opportunity to take out, you know, the mature growth and allow new growth to follow in its footsteps, and then convert that wood, which that wood at that point is 50% carbon, into long-lived wood products that store that carbon and turn those and use those products for building our buildings and cities, and turning out effectively our buildings into long-term carbon sinks. And at the end of that service life of that building, that wood will only release as much carbon back into the atmosphere as the tree has absorbed during its lifetime, whether that's through incinerating it or rotting and decay. The wood industry has been pretty good about very efficiently processing wood that comes out of the forest. I mean, if you look back here at this chart, the 1940s, roughly half of a trunk was wasted and incinerated or landfilled. And whereas today, you know, the wood industry is effectively using 99% of the trunk, and some of that in the form of residues that are then used for biofuels to provide their own energy. And as long as that comes from sustainably managed forests, that is a carbon neutral energy source. Many green building systems also increasingly rely on, while initially wood was kind of you know, more recognized in kind of a prescriptive category, many green building rating systems rely on the performance-based evaluation of building materials, assemblies, and entire buildings, and through life cycle assessment. And that's where environmental product declarations, so-called EPDs, have increased in importance, and a lot of these rating systems have started to recognize those. EPDs are independently verified reports on the environmental performance of products. They're based on life cycle assessment, and they have validity worldwide because they conform to ISO standards. So it's like the nutritional label on your food. You can kind of quickly compare different products against each other and see which one you think you might prefer based on its environmental performance. The wood industry, especially in Europe and Asia, has been kind of the leading developer of EPDs, and the North American wood industry is kind of following in its footsteps. There are a lot of opportunities that have arisen with new technologies. I mean, our digital fabrication is offering the ability to manufacture wood, in a highly customized fashion without, significant loss of productivity. Some of that kind of gets lost in, formal explorations, which I'm not a particular fan of. So I'm really more interested in kind of using these computer-based design and fabrication processes to resolve issues of material use, waste minimization, and structural efficiency, and really leading to the overall optimization of a structural system. Because you're able to create some of these geometries that are very complex. In the end, it's usually still workers in the field that assemble these in a very labor-intensive process by hand. Wood also, has historically had high levels of prefabrication due to its lightweight. Even, going back centuries, carpenters would prefabricate offsite, bring it to the site and direct structures. And then that's where the term, raising a barn comes from. And whether that's prefabricated components or entire wall and floor panels, or entire prefabricated spatial modules, prefabrication really offers alternatives to conventional building practices, which are often plagued by inclement weather, exceeding budget, or chronic delays, and then a lot of times poor quality of construction. So prefabrication offers the ability for processes to occur simultaneously rather than in a linear fashion. They tend to be less dependent on the weather. They offer dry and safe working conditions, better quality control, also reducing waste on site. So you're not trucking a lot of raw materials to the site, then you have a lot of waste that you have to get rid of, or landfill in the worst case. So a lot of that waste can be separated and taken care of right there in the workshop. Also reducing the impact on the neighborhoods that these buildings are going up in terms of noise and interruption is increasingly relevant. But that said, I do like all building materials. I'm a fan of wood, obviously, but I don't want to use wood simply for the sake of using wood. So let's use wood where it makes sense. And, wood does play nicely with other materials, right? Let's use it, even an all timber building is not gonna get away without using any type of metal connectors, or, let's employ hybrid construction techniques where where we can exploit the strength of one particular material while compensating for the weakness of another, such as, using steel for tension and wooden compression, or, a concrete podium that, keeps the wood nice and dry and allows us to do larger spans. Where I see a lot of development happening is in composite systems, where you use two materials together, such as, wood floor concrete systems, where you're taking advantage of concrete's mass for acoustic and fireproofing, and then, also the structural capacities of concrete and compression and wood and tension here. But at the same time, when we look at these composite systems, we have to keep in mind what's going to happen at the end of the service life of these buildings. Like in the top right, you can see up here, this is a mechanical shear connector that connects the precast concrete slab to the wood structure down below, and ensuring the composite action, structural integrity of the system, but at the same time really also facilitating disassembly at the end of its service life and easy separation into the different kind of waste or recycle flows. We have over half of the world's population living in urban areas now, and by 2050, it's going to be about 70%. And it doesn't matter whether you're going to be in an industrialized nation or in an emerging economy, they're all going to have to, provide more sustainable and affordable housing. But at the same time, we also need to, reduce our carbon footprint. These new mass timber products have the opportunity to build taller and denser, and turning our cities into carbon sinks rather than emitters of CO2 emissions. Wood's also great in increasing density in these areas, whether that's an infill project where you're minimizing the truckloads of materials that go in, and also reducing the noise impact and disruptions on the neighborhood. Also increasingly important in these inner city environments are fine particulate emissions that you can reduce with high levels of prefabrication. Also taking advantage of the significant structural reserves of some of our, steel, concrete, and masonry structures by rooftop additions. This example here, second to the left, is a two-story 1960s housing development and received a two-story addition in wood, and effectively more than doubling the livable space. And taking advantage of the embodied energy of the materials that are already there. And lastly, also looking at, we have building stock from the 1950s to the 1980s where the envelope has really reached the end of its service life, but the structure, is totally fine, and there's no reason to tear them down. So increasing the thermal properties of the envelope by recladding them with highly insulated prefabricated panels, and that process actually happens a lot of times while the buildings are fully occupied, and so increasing the lifespan of the structure and the embodied energy that kind of already went into it, and 50 something years ago. Lastly, I want to close with that slide in terms of the potential for wood. I think these mass timber products have opened up manufacturing prospects and added value potential for a lot of rural regions that have abundant timber resources, and creating jobs, well-paying jobs, and then also really connecting them with the urban communities that will actually consume their products for building their buildings and cities. Also continued research into all wood products, reducing kind of the number of metal fasteners or alien materials that might make it hard to repurpose and recycle at the end of the service life. There's also significant potential in using hardwoods structurally. Most of virtually all of our wood that we're using in structural application is softwood, but there's a large number of hardwoods in our forests that are not being put to a higher use. And this, for example, up here to the top right is a laminated veneer lumber out of beech that exhibits great properties and great strength properties. So really putting some of our hardwoods in a healthy forest mix, depending on which part of the country you're in, is a mix of hardwoods and softwoods. And hardwoods also tend to be a little bit more resilient to temperature change than coniferous woods are. And then, the Achilles heel obviously for the wood industry are the adhesives, which still are heavily reliant on petroleum-based products. But there's a lot of research going on bio-based adhesives or other forms of bonding technologies such as friction welding. And then lastly, the steel and the concrete industry, they've over the last 50 or 100 years, they've been able to kind of get a good system down and that has been standardized, whereas the wood industry is still really, and the mass timber industry is still really in its infancy. And every building that goes up is really kind of a custom product. So the goal of creating standard details, open building system, kind of a database of details and connections that can easily be shared among architects and designers, so that we're not reinventing the wheel every time. So with that, Martin, I'm going to close, and I look forward to listening to the other panelists. Thank you.
Right, fantastic. Yeah, thank you so much for that presentation. And if anybody has questions, we can just feel free to drop it in the chat box, so we can sort of keep the presentations rolling, but continue to engage. And then Uli, I don't know if you want to drop contact information in case anybody wants to reach out directly with any questions.
I can do that. Yeah.
But without any further delay, Lionel, are you ready with your presentation?
I am. Hold on one second. I'll get it fired up.
All right, perfect.
All right. Thank you, Martine. So the title of my presentation is Strength Through Transparency, the Drive Towards Zero Carbon Concrete. My name is Lionel Lemay. I'm with the National Ready Mix Concrete Association. We represent ready mix concrete companies in the United States and their suppliers, so cement, admixtures, aggregate, and so forth, among many others, including the equipment manufacturers for manufacturing plants and trucks and so forth. So we do education, we do research, we do certifications, and of course we do advocacy codes and standards advocacy in the United States. We do have some international members, especially many of companies that are in the concrete industry or cement industry also are international companies. So we do have some international members. So is concrete sustainable? That's the question, right? So we think so. You know, concrete's one of the most versatile materials. You know, almost every building, bridge, dam, road, you know, home uses a significant concrete, whether it's a wood building, a steel building, or all concrete building or structure. It's resilient, usually the material of choice when trying to resist, you know, the wrath of Mother Nature when it comes to, you know, weather events, hurricanes, tornadoes, seismic events, fire and blast. In terms of durability, it's concrete's used for, you know, structures that are designed for centuries. And then in terms of cost effectiveness and efficiency, you know, it's cost effective, it's strong, it's available everywhere on the planet. You know, a pumpable, finishable shape to any shape imaginable. However, when we talk about embodied carbon, you know, we tend to think about the actual formulation of concrete or the mix design. And, you know, here's an example. When you look at this particular mix design, the question becomes, is this sustainable concrete? It's 50% Portland cement replacement. And I think most people would say, yeah, that is sustainable concrete. But I'm going to suggest that maybe we're not sure, because there are so many applications for concrete and so many, I would say, fairly rigorous needs from both the owner side, architect, engineers, and contractor side, that you have to really make sure you understand what the use for that concrete is. So, for example, if you have high early strength concrete, perhaps 50% replacement is too high for that particular application, whether you're turning forms, post-tensioning, trying to open a road very quickly, or lifting tilt-up panels, or whatever the case. So you could probably do it with 50% replacement. You really have to think about it. When it comes to mass concrete, 50% replacement might not be enough. So you would not have a durable concrete that could control the heat of hydration during the placement of these mass concrete elements. And so that mix design that I showed you, that most people would say is a sustainable mix design, may not be, in fact, meeting all the performance criteria. The point I'm trying to make is, you know, what's a sustainable structure? Well, it has to meet all the traditional performance requirements of the owner and the design team and contractors. For example, strength, durability, fire resistance. It has to be, you know, quiet for buildings. It has to be economical, easy to build. But now, in the last couple of decades, we're now focused also on this additional criteria, which is minimizing carbon footprint. So let me explain how the concrete industry is trying to meet that challenge. Just a few milestones. I would say back in the mid 2000s. Not to say that the industry wasn't moving towards more sustainable structures before then, but our association really focused on this in the 2006, where we launched a conference specifically focused on trying to reduce carbon footprint, bringing all stakeholders together, exchange ideas, and see if we couldn't develop a pathway to more sustainable concrete. In 2009, we actually adopted a set of strategies to get there. And there were many different goals in there, but in terms of carbon, it was to reduce carbon footprint by 30% by the year 2030. We established the MIT Concrete Sustainability Hub through our sister organization, the NRMCA Research Education Foundation, with the main focus of trying to develop measurement criteria and processes to get to lower carbon concrete. Life cycle assessment really was the main measurement tool that we all decided on, that this would be the way to measure our progress towards more sustainable concrete. We also developed at the time what was called the Sustainable Concrete Plant Guideline, which was the basis for certification, much like FSC, very rigorous set of standards. Now, I would say that we were probably ahead of time, because at the time, really, there was no demand for any sort of a certification for the manufacture of concrete. And really, it never really went anywhere, because certification, the only way a certification is successful is if there's demand for it. I'll get back to that near the end of my presentation. What really sparked our industry to really make some change was in 2011. Two things were happening. One, if you remember, LEED 2012 was being developed, which turned into LEED 2004. It took a lot, or excuse me, LEED version 4, which took a lot longer than everybody ever thought. But at the time, LEED 2012, as it was being developed in 2011, had a section, and still does, on measuring embodied carbon along with other impacts using the idea of life cycle assessment and environmental product declarations. At the same time, Architecture 2030 Challenge was initiated for products and set a target for reducing carbon footprint for building materials, and set out LCA and EPDs as the way to measure that progress. And then also at the time, Carbon Leadership Forum, that was right around the time that CLF was actually established. And what we did is we signed on to the Architecture 2030 Challenge. We were obviously involved in CLF right away, and also helping develop LEED, making public comments, being involved as much as we could. But we immediately started by developing, because we signed on to the 2030 Challenge, we had to develop the product category rule for concrete, which we did through the Carbon Leadership Forum. That was established in 2012. We established our first set of benchmarks for concrete back in 2014. So that's when we issued our industry-wide EPD for concrete. And we've since issued our third version of the industry-wide EPD. And we've been able to demonstrate a 13% reduction. Now, you might say to yourself, wait a minute, 13%, that's not all that much. I'm actually quite proud of that number. And the reason being is this. I would say, and I don't know a good number, but I'm going to say that 95% of buildings that are being built have absolutely zero sustainability goal. And so it's really business as usual, unfortunately. The 5%, or maybe even less than that, that do have sustainability goals sometimes need some work with regards to the way that those sustainability goals are established. But the point being, there's not that many buildings that have that sustainability goal. I think what's going to happen, it's a vocal minority, and eventually that that's going to grow. And so we have to be cognizant of that. And I think as a result, we're going to see significant reduction in carbon footprint, because all these buildings that have concrete in them will have that goal and thus have reduced carbon footprint. Well, we've been doing a lot, as you notice, there's a lot of education involved. And the latest piece of education that we're really pushing is this idea of a top 10 list for reducing concrete carbon footprint. I can't go through it all today. It's a 1-hour presentation. Be happy to do it at a later date. But I'm just going to point out a few things that if you're not doing this, you're really not serious about carbon footprint reduction. Number 4, using alternative cements. So I don't know if all of you know about blended cements. These are alternates to Portland cement. Basically what they are is Portland cement combined with other materials. The most popular one is just simply called Portland limestone cement. It has 15% limestone interground with Portland cement. It performs exactly like Portland cement, and you can still use all of the other methodologies for reducing carbon footprint. If your spec doesn't permit the use of blended cements, ASTM 595, take note of that. Going back and look at your spec, because I know all of you love looking at specs. Go back and look at your spec and see if you permit ASTM C595 in there. If not, do it today, because right off the top, you'll reduce concrete's carbon footprint by 10% and get the same performance. Who can argue with that? Anyway, there are plenty of other things here that you can do, and you can go to the YouTube, go to YouTube and go to the Build with Strength channel, and you can watch a short, well, not that short, it's 20 minutes long, that talks about these top 10 ways. The future, 2020, that's where we're at now. Ed Mesria and the Architecture 2030 Challenge actually changed the goalpost on us just recently. Said we have to actually get to 0 by 2040, not 2050. That's okay. You know, I think we can do it. There's so many things going on in the concrete industry that will help us get there. We did launch again our concrete sustainability conference, retitled Global Concrete Summit, only because we can reach the globe now that we're all online. We're behind the SA 2050 challenge, and I'm proud to say that our industry has over 33,000 concrete EPDs. So 33,000 products have been entered and have environmental product declarations that have been entered into the EC3 tool, which is great. In terms of 2030 and beyond, very recently, the Global Cement and Concrete Association, that has over 40 cement and concrete companies that belong to it, announced that they have a 2050 zero carbon footprint goal. A couple of other things to point out. We are prepared as an industry to address things like material ingredient disclosure. We do have a report that will do that. We also took that that document I showed you earlier on responsible sourcing, and we developed a worldwide responsible sourcing scheme called Concrete Sustainability Council. So again, the demand for it here is relatively low, but we're ready when the demand does start. In terms of how we're going to get to zero carbon concrete, it's really about innovation. There are an incredible number of companies out there that are working on really innovative ways to reduce concrete's carbon footprint. Number one, again, Portland limestone cement. If you're not using that, you're not serious about lowering concrete's carbon footprint. But just a few other things. I think that's really exciting. Things like harvesting fly ash. There's 1.5 billion tons of fly ash buried in the ground. Why is that? Well, we've been burning coal to generate electricity for over 100 years. And we've only been using fly ash in concrete for the last 40. And honestly, even today, not all of it's being used every year that's being produced by coal power generation plants. So some of that is still going in the ground. This is sad. Anyway, companies are beginning to look at those harvested or those landfills and being harvesting fly ash and using it in concrete. So I would say that's a big deal. I think in terms of construction, Uli pointed out this idea of being more efficient. Things like self-consolidating concrete, 3D printing is super exciting, and things like fiber reinforced concrete. I mean, the idea of having to place reinforcing in concrete and making it a three-step process, building a form, installing the reinforcing, and then placing in the concrete. If you can do it all at once, including having formwork, not even having formwork, so 3D printing, fiber reinforced concrete, end of story. No other additional finishes, nothing. You got a fire resistant, resilient structure that could be incredibly attractive. Still a long way to go on the 3D printing side, but I think it's promising. And then, you know, there are really exotic concretes like geopolymer concrete that doesn't use any Portland cement at all, just uses pozzolans or other SCMs with an alkaline activator, which is why SCMs work in concrete anyway, because of its alkaline solution in the concrete. So, you know, today you can make concrete that has nearly zero carbon footprint. There are some other innovations, just don't have time to go through them all today. And the results are fantastic, right? So companies like Walter P. Moore and other structural engineers and architects are using the data that we've been able to develop over time to actually demonstrate lower carbon footprint. All these buildings used the LCA methodology to demonstrate that they had a lower carbon footprint. And of course, there are hundreds more, but these are some of the more impressive ones that are published. And so very proud of the fact that the data is there for structural engineers and architects to use to measure concrete's progress towards a lower carbon footprint. Thank you.
All right, excellent. Thank you very much, Lionel. That was a lot of great info. So without further ado, and again, like if anybody has questions, please drop them in the chat. We can address them as we go. Hopefully we'll have some time at the end to have a bit more open-formed discussion before everybody has to head off, because don't want to force anybody to stay longer than they want to. So without further ado, Mark, let's pass it off to you.
Okay, let's see.
And then Lionel, if you want to drop your contact information in case anybody wants to reach out directly with questions. And I'll be providing the presentation material to everybody who's signed up on the event.
Okay, are you seeing my screen?
Yep, looks good. Take it away.
Okay, let's go to, there we go. Okay, so I appreciate the opportunity to talk a little bit about steel as a sustainable construction material. I'll start with some numbers, but also what I think is the most important sort of non-high-tech, non-glamorous aspect of steel relative to sustainability, and that's its ability to be recycled. I think, you know, everyone knows this, but it's really important. It can be recycled over and over, and across multiple applications. That's important as well. You know, a steel beam, we always say a steel beam can become any other steel product. It can become a refrigerator or a car door or a food can at the end of its life. So just some numbers in the U.S. The producers of steel in the U.S. have reduced their energy intensity and CO2 emissions intensity, so that's per ton of steel over the last 30 years or so by a really significant amount, by more than a third. You know, I already mentioned recycling, structural steel especially, you know, hot rolled steel sections, beams, channels, that sort of thing, are recycled at a near 100% rate. One of the producers of that product in his presentations always likes to say that nobody's throwing a steel beam into a landfill. It has value, so it gets recycled. And the numbers are really substantial. In a given year, somewhere between, this is just in the US, somewhere between 60,000 and 80,000 tons of steel is recycled every year. The last year for which we have good data, I believe the number was about 67,000 tons of steel recycled. And because of that, some products, especially construction products like structural steel and rebar, are produced with near 100% recycled content. So, you know, in today's sustainability climate, it's important that the users of steel or any product have the information that they need to make sustainable design decisions. And our industry is proud of the fact that we have available a significant number of industry-wide EPDs for nearly all steel construction products, not just framing, but things like steel decking, steel joists, steel doors, all those sorts of things. And more of those companies are producing their own producer-specific EPDs as well. Lionel mentioned the PCR. We also have a PCR for steel products. In fact, we just completed the 5-year renewal of that PCR, so there's a new version as of just a month or two ago. And we also are just about ready to release new life cycle inventory data for steel products. These would be sort of semi-finished steel products at the level, at the coil level, one exception being structural sections, which has its own set of data. And this is important for any anyone that's doing any kind of life cycle assessment study that would include steel. So the most recent data on steel production in North America, this is North American data, will be available, I hope, by mid-November. And I think it is important to point out, if it isn't obvious, that steel is just kind of everywhere. It's really vital to a lot of aspects of what we do every day, and maybe most importantly to renewable energy projects. The wind towers that are becoming more and more common, most of those wind towers, not the blades, but the towers are made out of steel, and some of them are quite gigantic. Also important to point out that it's not just environmental. I mean, that's what gets the most attention, and possibly for good reason. But there are two other aspects to sustainability, and those are important as well. I already mentioned about how, you know, steel is sort of critical to a lot of aspects of daily life. Things like safety standards, which are very stringent and we take very seriously here in the U.S. Maybe not so much in some other parts of the world, but important as well. You know, this concept of the circular economy is getting a lot more attention. There's a relatively new but very active ISO standard, ISO technical committee now that deals specifically with circular economy, how to measure it, how to define it, and we feel like steel is just a natural fit for the circular economy, not just because of the recycling aspect, but also because, you know, it's a durable, long-lasting product, especially in construction. It can be designed to be very flexible. It can be designed for easy disassembly so that as building occupancies change, the building can change to meet those without starting from scratch. And one other point to make is that the co-products from steel production, any production process has co-products, and in steel, the vast majority of those have found other uses, whether it's processed gases that are used for heat usually in the same facility in some way, to products like slag, which is very common, and I think Lionel mentioned that as well, often used in concrete construction or as road beds or even as fertilizer products. So if there's one thing I could leave with you today as being what I think is most important from a construction standpoint when steel is used, is to understand that the steel produced in the U.S., and this shows United States, but it's pretty much the same in Canada and Mexico. So in North America, the steel produced in North America, the emissions intensity of that steel is lower than any other major steel producing country. These are the 7 largest steel producing countries. And as you can see, in some cases, dramatically lower. So that if you were to construct a building, a primarily steel framed building, and that steel was sourced from, pick a country, India, versus sourced in North America, then you start at a distinct disadvantage from an emissions standpoint. It tends to get into a political discussion, which I prefer strongly not to do, but it's just a fact. This is an independent study, by the way, that we had nothing to do with. This data is readily available. And the steel industry, of course, doesn't stop there. As far as the future, there's a significant amount of research ongoing by both by AISI as an association and also individually by its members, both in North America, which is the region that we represent, but also globally. And I won't go through all of those. There are several types of projects that are being considered, most of which are in process in some way, in either demonstration projects, some beyond demonstration projects. One of the ones that seems to have the most potential is the idea of using hydrogen as a reduction agent to produce iron, essentially to reduce iron ore to a usable form of iron in steel production. That's done typically right now in a blast furnace, but it can be done using hydrogen. And if that hydrogen is produced using renewable energy, it becomes a significantly reduced carbon profile for the steel that is produced in that manner. One of the other maybe kind of obvious options for reducing the footprint of steel is in electric arc furnace steel production, where electricity is the primary energy source, is the increased use of renewable energy. And that's something that's getting a lot of attention and is beginning to be implemented. These are some examples, three of the examples, SSAB in Iowa, Nucor, excuse me, Nucor in a plant in Missouri, a new plant, and Evraz in I believe, where's Evraz? In Colorado, are using renewable energy sources, two of them wind-based and one solar-based, to provide all or nearly all of the electricity needs of these facilities. So that's a development that's really exciting. And the other thing that I'll mention is a brand new, just announced last month. It's an example of carbon capture in a blast furnace application. The Department of Energy awarded funding to ArcelorMittal at their plant in Burns Harbor, Indiana, to do a pilot project that would result in capturing the CO2 that is produced at their blast furnace. So that's an exciting development as well. So that's been a very brief introduction to steel as a sustainable material. Hopefully allow time for questions. In summary, yes, steel is everywhere. The fact that it's highly recyclable and that it lasts for a long time makes it a good fit for the circular economy. And as I pointed out, the U.S. produced steel, North American produced steel, has really one of the lowest emissions intensities in the world, and to the point where I typically tell architects that one of the first and most sustainable decisions that can be made if a building is going to be a primarily steel building is to ensure that the steel is sourced from American sources. And that's it. This is my contact information. Glad to answer any questions now or later using that email or phone information. Thank you.
Excellent. Thank you. Thank you very much, Mark. That was awesome. And by some miracle, we've managed to stay just about on time. And so we do have, I guess, 9 minutes for questions now. So if anybody wants to drop something in the chat or just unmute yourself, I'll open it up to people. I know I have a handful of questions. And keep in mind, I know Uli has a hard stop at 12:30. I don't know how long other people will be willing to stay on. I'm happy to stay on for a couple minutes, but let's take it away. Anybody with questions? Okay, I'm happy to, I'll get it kicked off. Go ahead.
No, I was just going to say there's a question in the chat about comparing the 60 to 80,000 tons of steel scrap to the demand, the overall demand for steel. And in rough numbers, I mentioned 67 million tons as the most recent year for which data was available. For that year, the production was approximately 90 million tons. So overall, 67 million tons of scrap went into producing about 90 to 92 million tons of steel. So you can see that the overall recycled content for really all steel produced in the US is very high.
Looks like there's a follow-up.
Go ahead.
Is the US produced steel emissions intensity lower than other countries because there's a greater percentage of electric arc furnaces, which has steel scrap as an input, compared to basic oxygen furnace, which takes iron ore with 10% scrap? So is it because of...
Yeah, so there are two reasons why it's lower. One is what, as the question mentioned, it has a much higher percentage of EAF production to BOF production. In the U.S., it's about 2/3 EAF to 1/3 BOF. Interestingly, globally, it's just the opposite. It's about 1/3 EAF in rough numbers. But the other aspect of it is the level of emissions control technology, or just the level of technology, steelmaking technology in general, which isn't better than everywhere in the world, but it's certainly better than a lot of regions in the world. So it's those two things combined.
So this is for steel and timber. How do applied adhesives, including foamed plastic insulation, constrain steel recycling? And then I also timber recycling.
I'm sorry, repeat that?
How do applied adhesives, including foamed plastic insulations, constrain steel recycling or mass timber recycling?
I mean, from a steel perspective, there isn't a lot of adhesive in most construction products. I guess there might be some. Small amounts of any kind of coating or adhesive can be accommodated. They just get burned off in the steel making process, and ideally, residue or dust collected in a treating bag house. It's not typically a big issue, I don't think.
Yeah, I mean, with regards to timber, so a typical glulam will probably have about 1% of its mass be adhesive, and then on the high end, when you're looking like at a Paralam or laminated veneer lumber, you're probably looking at about 6 to 7%. So the content is relatively low, but I mean, some of the new mass timber products such as CLT, they haven't been around long enough where you actually I'm actually not aware of any CLT building that has come down that's been recycled, unless we're temporary structures maybe. I mean, depends on what you're doing with it. If you're obviously incinerating it for energy generation, you're obviously releasing those emissions into the atmosphere. If you're shredding it up and you're using it for making OSB or some other engineered wood product, it's really not an issue, because those products you'll add obviously add additional adhesives. I think it's mainly a concern when you're incinerating it, and then you're dealing with potential emissions from that. But again, the percentage based on the mass of the overall material is relatively small.
Okay, and then a question for Lionel. Do you have experience with specified concrete GWP or global warming potential limits, or any feedback on the implementation? Several concrete suppliers I've spoken to don't have experience with this. It seems like another prescriptive requirement that would be difficult to achieve, but would also force the suppliers to promise low carbon concrete.
Yeah, so in fact, we do have an example that I'd be happy to distribute to the group where we go through the calculation. And we suggest that instead of trying to put carbon limits on each individual mix design for every application, whether it's foundation, columns, slabs, beams and so forth, different components of a building, that you should try to calculate the overall carbon budget for the building. Now, to do that, of course, you need to know a little bit about, what are the limitations, or, how far can you go with, let's say, SCM replacement in different applications. The reason we suggest putting the entire carbon budget as a target for the building is because it does then provide some flexibility. For example, let's say you guys specify, structural engineer specifies 5,000 PSI at 28 days for post-tension concrete slabs. The contractor comes along and says, I want a post-tension in 2 days, so I need 8,000 PSI in 1 day. Well, I'm sorry, but 5,000 PSI at 28 days and 8,000 at 1 day are not compatible. Clearly, that 8,000 at 1 day is going to have a significantly larger carbon footprint. And so there may be some compromise during the project, but what it does allow, if you have that total carbon budget established for the building, it does permit a contractor and producer to say, okay, I'm going to go, instead of just 70% replacement on the mat foundation, I'm going to go 90% replacement, or I'm going to use additional innovations to reduce the carbon footprint of the mat, which can overcome perhaps a slightly, over budget carbon footprint on the slabs. I've got an example of how that's done. You still need to have some idea of what the carbon footprint or the carbon footprint could be for each mix design, but that's what the industry-wide EPD is for. We have literally 72 mix designs that you can go in, take a look. It doesn't have everything, and that's what's going to, in the future, we're going to be including other mix designs, additional, higher SCM replacements, the use of Portland limestone cements and other blended materials. So you'll have a larger library of mixes that you can use for the what if scenario in design, right? And compare those to the benchmarks. We have a set of benchmarks, what's the average carbon footprint for average mix designs, and then the what ifs for, pushing the envelope. And anyway, that's our recommendation. Again, I'd be happy if you just email me, since I did include my email. I wasn't smart enough like Mark to put the email right in the presentation, but I did chat it to you guys, and just send me an email and I'll send you that example.
Mm-hmm. And so thanks again to we're just about at 12:30, so I want to respect anybody's time who needs to hop off. But thank you again to Lionel, Mark, and Uli for joining us. And I do want to encourage everybody, like Lionel's saying, send them emails. Let's keep this conversation going. I don't think anybody would think that you can boil these materials down to a 15-minute presentation. So it's going to be a continued learning process. Keep reaching out, keep asking questions, join the CLF, and let's keep having these conversations. So I'm happy to hang on for a little bit to